Hi everyone, I'm Sir Jundel and welcome to our math tutorial. In today's lesson, I'm going to teach you how to solve direct variation easy and meaningful. I want to start with this illustration. One of the famous statements says, "What you think is what you are." So think positive to yourself and it will give you positive results. Direct variation is like that. In this pandemic time, have you ever saved an amount as your savings? In our illustration, Jello saved an amount as his saving because he wants to help his mother whose work has been affected of the community quarantine implemented by the government due to pandemic. The variety of rice he decides to buy costs 40 per kilo. Jello went to the market and decided to buy a rice cost 40 per kilo. As the table shown here, we see the relationship of two quantities, the number of kilos of rice and the total cost of rice. When the number of kilos of rice increases, the total cost of rice also increases. And that's what we mean direct variation. Direct variation is a relationship between two variables in which one is a constant multiple of the other. Constant of variation, it is the constant unchanged ratio of two variable quantities. We can see in the table, when Jello buy 1 kilo of rice, the cost is 40. If he wants to buy 2 kilos of rice, the cost is 80, so on and so forth. Here we can see that as one quantity increases, the other quantity also increases. As one quantity decreases, the other quantity decreases. Again, that's what we mean direct variation. Direct variation occurs when one quantity is equal to constant times the other quantity. And this constant, it refers to the constant of variation. And it has this formula represented by k is equals to y over x. This direct variation has statements. Varies directly as, is directly proportional to, and is proportional to. The quantity y varies directly as x if there exists a non-zero constant k such that we translate this one as y equals k constant of variation times the independent variable x. So y is our independent variable and x is our independent variable. The quantity who varies directly or the quantity who depends to another quantity is our dependent variable, and it plays in this equation in the left side of the equation. Since y is our dependent variable, x is our independent variable. So y depends to the value of this independent variable. That's why y plays in the left side of the equation and x in the right side of the equation, because y depends to the result of this value. There are steps to solve direct variation. The first step, make table for the given. The second step, determine the constant of variation k using the formula k is equals to y over x, or just simply divide the first part of the given. The third step, translate the statement varies directly as to equation and assign the value of k to that equation. Then the fourth step, assign the value of the last part of the given to the translated equation. We operate them in order to find the unknown. I'm excited to go now to our examples. Example number 1. A worker's paycheck P varies directly as the number of hours H worked. For working 20 hours, the payment is 1,000. Find the payment for 45 hours of work. In step 1, table for the given. Table for the two quantities, the hour and the paycheck. We write the hour in the first row and the paycheck in the second row of this table. The paycheck is our dependent quantity or variable because it depends to the number of hours consumed. In the table, if 20 hours consumed, the paycheck is 1,000. That's why paycheck is our dependent quantity and the hour is our independent quantity. Whereas to find the constant of variation, and the formula to find the constant of variation, k is equals to p over h. In other words, the numerator, the dependent variable, divided by the independent variable, or we divide them. We divide the dependent variable by the independent variable. That's why in this example, we have 1,000 divided by 20 is equals to 50. So 50 is our constant of variation. Next, we're asked to find the equation of variation. And we know how to translate this one. P varies directly as H. Paycheck varies directly as the number of hours. In other words, P is our dependent variable, must be placed in the left side of the equation. And H is our independent variable, must be placed in the right side of the equation, times the constant. of variation. So to find the equation of variation, we translate this statement. We translate P varies directly as the number of hours. So P is equals to K times H. Assign the value of K to the equation. So we have now this equation, P is equals to 50H. And we have to find the payment for 45 hours of work. So we just copy the translated equation, P is equals to 50H, to find the payment for 45 hours of work. So we just copy that one here. So 50, so for 45 hours, 45 is for our hour. So assign 45 as our time to H. So we multiply them. 50 times 45 is equal to 2,250 is the payment for 45 hours of work. Therefore, 2,250 pesos as payment for the 45 hours of work. Example number 2. Joas is riding his car leaving Ligan City to visit his grandparents in Lanao del Norte. He travels at 70 kilometers per hour. The table below shows the time in hours T traveled and the distance in kilometer D covered by a car. So Joas wants to visit his grandparents in Lanao del Norte having these two quantities, time and distance. So the table shows in 1 hour it covers the distance 70 kilometers. In 2 hours it covers 140 kilometers. So on and so forth. As the time increases, the distance also increases. So this is a direct variation problem. So we can say that this is a direct variation problem. As one increases, as one quantity increases, the other quantity increases. As one quantity decreases, the other quantity decreases. And that's what we mean. And in this example, we're asked to find constant of variation, equation of variation, distance after 5 hours of travel. So for the solution, we have this table for the given, for the two quantities, time in hour, distance in kilometer as D. To find the constant of variation, K, we just simply divide the dependent variable and the independent variable. So dependent variable in the numerator, independent variable in the denominator. So we divide 70 divided by 1 equals 70. 140 divided by 2 equals 70. Since the constant of variation is unchanged value of the ratio of these two quantities, 70 divides a 1, 70, 140 divides a 2 is equals to 70. Unchanged value of the ratio of the two quantities. So we have now 70 is the value of K. 70 is the value of K as constant of variation. So to find the equation of variation, we translate D varies directly as T. In the problem, we just simply translate varies directly as in the problem D varies directly as T. So D are dependent variables, so placing that in the left side of the equation equals to the constant times the dependent variable T. So we translate D varies directly as T and assign 70 to K to have this equation, translated equation. And to find the distance after 5 hours of travel, we just simply copy the translated equation here. So 70 times 5 hours of travel, 5 hours is our time. So T, we multiply them, 70 times 5 will give us 350 kilometers as our distance traveled after 5 hours. Remember, direct variation, as x increases, y also increases. As x decreases, y also decreases. As number of kilos in our illustration, example, the total cost y also increases. If number of kilos decreases, the total cost also decreases. And this direct variation has this equation, y is equals to the constant times the independent variable x. Thanks for watching and make sure to subscribe to get more videos in the future. See you there.